Good afternoon. This is just a short introduction before we start the formal meeting. So this slide will stay on for a few moments before we start actually the lecture at 3 o'clock. So good afternoon, gentlemen. This afternoon we have MHO-Co to give us a presentation on their SES CTVs, their operational experience so far. And I will hand it over to you at MHO to start your presentation, if you would, please.
Yeah. First, we have just a little video where we can show you what a SES vessel is as opposed to a hovercraft.
Okay.
In short, the SES vessel is a catamaran on the sides, and on the fore and aft we have skirts like on a hovercraft. So the principles of sailing with an SES boat is in some ways compatible with a hovercraft. It's got the lift fans. It's got a very big lift fans that are pumping air into the between the hulls and the skirts, which lifts the boat 1.5 meters out the water. So only about the draft at the jets are just about under 1 meter. The concept was developed by MHO in Norway, and the first boats were launched in the early 2000s, called the Skjold class, for the military, for the Norwegian military. And they had gas turbines for the propulsion jets and very big MTU engines for the lift fans. On our boats, the latest edition from MHO is propelled by 4 Scania D16, putting out, Richard, correct me if I'm wrong, something like, what is it, 850 kilowatts each? Richard, do you have the exact number?
They're about 1,100 horsepower each.
Yeah, so about 850 kilowatts.
Yeah,
so
around that figure, yeah.
4 of those and 2 in each side, going into a gearbox and out to one water jet on each side. The maximum speed that we've had on these boats is about 50 knots. The Skjold class, the military version of the boats, which is 35 meters long, has a maximum speed around the same, but obviously with a lot more power. Our experience so far is that the boats are really good at doing high speed, and even in some sea state, they're still doing really good speed. The calculations that we've made compared to our traditional catamarans is that these SES boats during a normal transit at 42, 44 knots, they consume about half the fuel per nautical mile as a conventional CTV. The downside, of course, for us is that they do not have the carrying capacity that our other catamarans have. Our traditional catamarans carry up to 60-70 ton cargo and fuel and passengers, whereas the SES boat has a maximum of 9 tons fuel and 5 tons cargo. So very well suited for a high-speed transfer of personnel or light cargo, even on fairly long distances. We did one crossing of the North Sea on one tank of fuel, but after that we decided it was just a little bit too much. So they've been doing a pit stop in Germany on the other transits across the North Sea. But I would say for about up to 300 miles in one run, they are a good option for moving personnel. Our experience, however, is not just for transiting and transporting people over longer distances. We have to deploy people on offshore structures, wind turbines and substations. And the challenge for these boats in these situations is that when they are sitting on the cushion and pushing onto a tower or a structure, the jets have to give quite a lot of output to keep the boat to stick onto the boat landing. In this situation, we have experienced quite a lot of cavitation in the water jets. Water jets are not really made for high output at 0 speed. That's more a tugboat that would be suitable for something like that. So it's a little bit of a contradiction, self-contradicting concept. We wanted to do well at high speed, and we wanted to do well at 0 speed. So there's probably some development needed in that. So I think we have the video ready now, so you can see what it is for those of you who may not have seen SES boats before. We thought we had the video ready.
It's okay. Whilst the video is being sorted out, Mik, have you, when you are attaching to a turbine or a structure, have you tried different approaches to how you could improve perhaps the thrust from the water jet? What I'm thinking of is that if you were to alter the relative pressure in the rear skirt, so reduce the relative pressure, you should be able to, I think, deepen the submersion of the water jet intakes, basically trim the stern down a bit. I'm just wondering if you've ever tried that to be able to increase the thrust which the water jets could give you.
Yeah, unfortunately, the skirts are fixed, and the only way to adjust the pressure between the hulls is through the vents in the hulls on the side. So we can't. But we have tried to lower the pressure in total, and by that, when it's pushing on, it does catch on a little bit higher, and keeping the bow there and pushing the jets down into the water. But unfortunately, I mean, we've been quite successful up to about 60% load on the jets, but after that we still get cavitation.
Right. Okay, thank you.
Can you see the picture now?
I can see the picture on my screen. I think you're yeah, you aren't running it at the moment.
No, let's try and run it.
There we go.
Yeah. And there you can see the skirts in the front, and pressure is building. And then you can also see that this is from the stern. This is at with not much pressure on the between the hulls. And there we see the situation where it's pushing on to the wind turbine. And here we can see the entire boat and the skirts and the tips, I believe. And that's the boat seen from the berth. Yeah, so that was to just to show you what SES boats really look like. They are 26 meters long. And how wide are they, Richard? 10 meters?
10 meters, yeah.
Yeah.
The newer generation ones are ever so slightly wider than I think earlier on in the video you saw one of the older models or MHO Flash. So the newer generation ones are ever so slightly wider than the other ones, which makes them quite difficult to go in a hoist.
Yeah. One of the challenges we've had with these is dry docking or lifting. It's been a challenge to find a dry dock near Grimsby, and so we've tried to use the travel lift. And with the belts around on the outside of the hulls, they have some keel fins, and these fins are quite vulnerable to the belts, so they get damaged. We've done some reinforcement of them every time we've had the boats up, so I think that problem should be more or less solved now. But now the guy with the lift is afraid that the carbon fiber, when it splits, is going to damage his belts. So that's been quite challenging. Apart from that, I think most of the technical issues we've had with the boats comes from this very hard vibration that we experience with cavitation. It seems that components are simply rattling off. A problem I've never heard before. This is a pipe cooler on a main engine where the pipes have simply rattled loose inside the cooler. And there are quite a few examples like this. This cavitation is quite severe. It's not something that you can actually that you think is terrible or horrible when you're on board the vessel, but the continuing of this vibrations the equipment just doesn't seem to like it. Hydraulic valves are breaking off the jets and hydraulic fittings and things that normally have a maintenance period of maybe 2-3 years is down to 2-3 weeks for checks and maintenance, because they seem to have quite a big effect from the cavitation. So yeah, I think that's the conclusion from our side is like I think I almost started with, is they're extremely efficient for transits and transportation of personnel, and I think we've seen foiling cats and foiling boats getting into fashion. And I think this SES is probably an alternative to those. And I think we will see more SES boats in places where the transit is more important and is the important bit of the operation as opposed to the pushing on. We know that 3 of these SES boats, 35-meter versions, have been built in Singapore by Strategic and are being delivered as we speak. The first 2 are already delivered, and the last one will be delivered, I think, this month. And they've gone down to the southern part of West Africa to operate on the oil fields down there. And they have round trips of up to 300 nautical miles per day, transporting technicians to the oil installations off the coast of South Africa, just north of South Africa. And they seem to be doing quite well.
Okay. Okay, so could we go on a little, Mik? How does, first of all, you were mentioning that such craft are very good for the longer trips. I'm just wondering how they fit into your fleet. They go out, these boats go out to the Dogger Bank, if I understand it right. So they're out to the more extreme distances for the wind farms. That's correct.
The latest of our own fleet, developed fleet, are sailing out to Dogger Bank now. Yes. Okay. These SES boats have been operating on the closer to shore, but it's about 100 kilometers. Is that correct, Richard?
Yeah, they've been working on a site called Hornsey 1 and Hornsey 2, which is between 100, 110 kilometers or 60 or 70 miles, nautical miles out. And they're able, in the right conditions, well up to 1.5 meters HS, they can make that trip in about 2 hours, 20 minutes, something like that. 2.5 hours each way, which is a significant improvement on previous CTVs that work there. Yeah,
our own CTVs, we still have one operating there, but we had more or less all our CTVs have been there, and they are between, I think, 4.5 and 5.5 hours for that same trip. So yeah, significant.
You can literally halve the transit time. Really, it works out around half.
So that then extends the day that the maintenance guys can spend out working on the inspection and maintenance.
Yeah.
Our bigger boats, slow boats in this connection, they stay out in the wind farm for up to a couple of weeks. They don't go in at night.
So that's another question I had. Excuse me, I'm asking questions, but just to kind of take us through it. But would these kind of boats serve as, if you like, personnel transit out to those boats which are staying out there for a couple of weeks?
Yeah, the technicians are normally sleeping on what are they called?
On the SOVs.
SOVs or platforms or hotel ships out in the wind farm. It's different wind farms have different concepts, but most of the wind farms have SOVs, service operation vessels, which is about between 80 and 100 meters long and have capacity for 45 to 60 technicians sleeping on board. They have the big gangway systems, but for a SOV, when they pull up to a wind turbine, it takes about 45 minutes to get into DP mode and get the gangway attached and get the people across, and then they have to go to the next turbine. So that's a procedure that's about 45 minutes, whereas a CTV, our conventional ones, or the SES boats, can do a change from one turbine to the next turbine and be attached in about 5-6 minutes.
Okay.
So our big CTVs, they stay just with our crew on board during the night, and then 6 o'clock in the morning, they take the technicians from the SOV and then they put them out on the different turbines, and then they just sit and wait until they finish their work, and then they go down and go to the next turbine, or go down and go back to the SOV. The SES boats obviously are what we call 12-hour boats. That means that the crew is not sleeping on board. The crew have to be in port at night, so they go out to maximum 13-14 hours per day, and then they are back in port. I see Trygve is asking if the older vessels have the same problems with the jets, with the cavitation, and then yes, like exactly the same jets, and whereas the older versions have MTU engines, they still have a lot of power, and that means that the water that we're trying to get through the jet, the jet can easily fit all the water, but it can't suck all the water. The vessels need to do speed ahead to get water to the jets for them to be able to push enough out to utilize the power.
Trygve, would you like to comment?
Is that Trygve Halvorsen?
Yeah, I can't get him to reply. Oh, no, sorry, Trygve. Yeah.
Yeah. Do I even have? Can you hear me?
Yes.
Yeah. We even got the video. Hi, Mik. How are you?
Hi, Trygve. Good. You all right?
Yeah, doing good.
Is the gangster that designed these boats or the original ones?
Exactly. Yes.
Yeah. So of course I wanted to reply to say that the old ones are perfect and the new ones are having issues. Yeah.
Yeah. No, for sure. I think, and I think Richard will can say if I'm right or wrong more precisely. The older ones had 1 meter more hull side.
Yeah.
Which is an advantage when there's a sea state, definitely. They have a higher
draft.
Yeah, they have a bigger draft when they're sitting, and they have a higher freeboard.
Yes.
When they are hovering, when they're doing transit.
They're also a slightly more stable platform when pushing on in a certain sea state.
Yeah.
And being the older ones have a pair of MTU 16V 2000 M72 engines. So they produce similar horsepower to a pair of Scanias, not quite as much, but they do seem to be more reliable in that form. And the older vessels have a double 90-degree gearbox configuration. So the engine is mounted quite high up in the vessel, and then it goes through the double 90-degree a center-link vertical shaft down to the jets. But it's the same as Mik said. It's the same model of jet that's on the new builds as the older builds. Whereas the older builds, the 2 Scania engines are sunk much lower in the engine room, much lower in the hull, and they go into a 2-into-1 reduction gearbox, Chimera reduction gearbox, which then outputs through a carbon fiber shaft, center link shaft to the jet. So they're not just different engine configurations, it's different drive as well, different drive line altogether. Because it is, like Mik said, there's a meter less to play with.
Okay, so you don't see that much replacement need on the water jet parts on the old ones, or are they a bit Because I left the company a bit too early to have those years of experience with the vessels, and we didn't see that at that time. So I'm wondering if that has occurred later on.
I think as time's gone on, I think that the older boats, I think, would last longer than the newer generation.
Okay.
It's the vibration aspect with the newer builds. There is quite a bit of vibration there.
Okay, understood. Thank you.
Sorry, just to a question on that. You were saying that the newer boats, they're driven by Scania.
Yeah.
There's more vibration from them than the older boats, or
yeah, there's more vibration from the newer generation with the two. Each side is basically two Scania DI16s.
Yeah.
That go into a 2-into-1 reduction Chimera gearbox.
Right.
Some of it is possibly the synchronization of both engines working together, keeping balanced revs on both engines. You know, it's quite. They have an operating system by a company called MCS, and quite a few times we have to get MCS to remotely connect because it all goes out of balance. So then they have to remotely connect to reprogram the operating system for those engines for them to run balanced. And obviously, you know, if one engine is running at a different RPM state than the other, you will get vibration. You know, one's working against the other, essentially going into a 2-into-1 reduction gearbox. So I think that's why there's more, you know, you get a bit more vibration out of the newer generation ones than you do out of the older ones, being a single engine configuration in each side.
Right.
But all, you know, the older and newer generations, the lift fan engines are all Scania DI13 lift fan engines. So there's one of those in either side.
Okay. Yeah, I can certainly imagine, as you've described it, Roger, that the having the two engines trying to feed into the one water jet, there's quite a control challenge there. And I'm wondering, this is where Trygve might be able to comment, but whether, although from the geometrical point of view, it's not easy, but actually having two engines into two water jets is probably a better solution if you can make it work from the geometry point of view.
Absolutely agree. We have seen two engines into one gearbox on many boats, tugboats, supply boats, ro-ro boats, ferries, icebreakers, a lot of different companies, shipyards, shipbuilders have tried and tested this, and it's always been a challenge. Two engines into one prop or jet or whatever it may be is sooner or later is going to be a challenge. My last experience was with a Danish guard vessel called Nordsøen, was built in '68, the year before the load line convention, but had two main engines into one gearbox and one propeller, and it was, they tried, like I said, it was built in '68, and we took it over in, I think it was 12 or 13. And in those years, they tried 3 different control systems on the vessel to try and control that. It was first by vacuum, and then by electronics, and I think the one they went back to was a vacuum system. So that there are quite a lot of different systems that can do that, but hard to find the right one.
The one that's controlling the Scanias at least does work, at least for a reasonable period before it needs reprogramming from the sound of it.
Yeah, the trouble with it is that it's not regular.
No.
So it could happen any time. So, you're trying to keep the vessels in service. Sometimes they remotely connect and the vessel can keep sailing and they'll adjust it. And they do have an RPM balancer, but if their engines are out of synchronization, the RPM balancer won't do anything.
No.
Can I just ask? You say that the newer engines are causing vibration. The older engines didn't cause so much vibration.
Yeah.
With the older engines, were they actually running in a separate 1-to-1 as opposed to a 2-into-1 system?
Yes. Yeah. There's a single MTU 16-cylinder.
It was just a single engine running
single engine, and then it goes through a 90-degree gearbox configuration. So it has an upper bevel gearbox and a lower bevel gearbox with a center link shaft between the two.
Yeah, understood.
And then a direct drive from the lower gearbox to the water jet unit. And the vessel's a lot more freeboard, and then you've got the room for that configuration. But with these being shallow, there just isn't the room for that.
Could you not put then replacing the two engines on the newer vessels to a larger single engine? Would that work?
I think they were. I'll let Mik's the designer, so I'll from the company.
I thought we was gonna go protest here, but yes, we do design boats here.
No, just thinking that if you got a single engine,
yeah,
that isn't vibrating, but you got two engines that do.
Yeah.
Could you not put a single engine into the newer boat, that, if necessary, put a larger engine in?
Yes, we've done a lot of research. We've had vibration measurement systems fitted in the boats for the last 6 months in both of them, and it's the main vibration is coming from cavitation in the jets. The other vibration that comes from the two engines not being in sync is also there, but that obviously, like Richard says, also causes more damage, because if one engine is taking all the load for a few seconds and then the other engine is kicking in, and then one engine is, so the engine is going 100%, 60%, 100%, 60%, that's not good for anything. A bigger engine, and that I think was what Richard was trying to say, the older version had a higher freeboard, so more space inside the hull, whereas the version has not so much space inside the hull.
Right.
So it's going to be, I think, probably we could find an engine that could do it, a new MTU 2000, but I'm not sure if. I mean, I know what the expense is going to be, because you'll have to change gearbox and everything else. So,
yeah. Well, obviously, that's.
And the boats are just about 1 year old, so yeah, it's a big cost if it was going to happen. And I think, to be honest, if the boats weren't pushing on the turbine so much, and by that they get all this cavitation vibration, I think the cavitation vibration is actually also making the load sharing fail, because it shakes everything on board. Like I said, with the pipe coolers, the pipes were actually shaken loose inside the pipe cooler, which I've never seen before on a 6-month-old pipe cooler. And I can just imagine that this load sharing equipment and programming with this cavitation vibrations also suffering.
I think that the selection of the 4-engine versus 2-engine was originally made due to cost, but the MHO engine is quite expensive.
Yes,
so I think you can change it to.
They're also out of production, right? The 16-cylinder.
Yeah.
Oh.
So we had to replace one of the MTU engines 3-4 months ago, and there was 2 for sale in the whole world, and luckily they were in Norway, because one of the old fast ferries up there had just been changed to batteries. So they had actually 3 of these engines sitting in their workshop. So we bought the 2 that they had. You can't buy them new anymore.
What would be the alternative model? What do MTU now supplying?
There's a Caterpillar engine that you can have instead for that kilowatt.
Oh, I see.
Otherwise,
Okay.
it's the problem is that exact kilowatt and that rating has been MTU only. That's why it's so expensive.
They also do a 4000 series now. They do manufacture a 4000 series.
Yeah, with much more kilos.
Which is a newer engine, but I think it's heavier and everything as well. So
yeah,
right.
And with the width of the hull and so on, it's going to be a bit of a challenge here. But like Trygve said, Caterpillar has an engine that is not far from being able to do it. However, all of the diesel engines that have been that are suitable for this are actually on something like 120-130% of what they are ideally loaded with. So it's always going to be a challenge. Trygve and I have spoken sometimes about a small or a battery pack or something, and then have an electric engine supporting, so you could actually run the diesel engine on the normal rating and then have an electric machine supplying the rest of the power. And then when the boat is not doing speed, the engine could be charging up the batteries again. So there are the new technology, the technology that's coming out these years is definitely worth keeping an eye on, especially if your name is Trygve.
That is okay.
Can I ask another question then of the group? Trim. How do you trim the boat?
I think.
I mean, if you were using a hovercraft, you'd use either
fuel
trim or water or something like that. Are these boats needed to be trimmed, or are they working without trim?
So
you can have forward ballast trim.
They have got forward ballast tanks, and you trim the vessel then, obviously with ballast, but also using the air cushion.
Yeah.
You use the air cushion to trim the vessel, depending on sea state, and there's also transfer mode as well, which softens the ride a bit.
We could ask Trygve what the latest is on development of that.
We like them to be a bit aft heavy, so a bit sitting a little bit too much on the arse, and then use interceptors to lift up. That's quite effective.
That's why I asked the trim program, because depending on the speed, you're either going to be nose up or nose down.
Exactly. And if you're in speed with waves, you would like to be a bit more nose up to not cavitate and ventilate the seawater systems.
Because otherwise you're going to get ploughing.
Yeah. Could I ask, Mik, it's very cool that you did a vibration study on this. Was that also for all vessels, or was that for the new ones?
That was just for the new ones. We've had on both Fast and Furious. We've had, but it would be quite easy to Rick knows exactly how to install the equipment, so we could take it off one of them if we thought we would need the data. But we have only been focusing on the new ones so far.
Yeah, it could be a good item for new marketing of these vessels and how to deal with Ørsted on this, I think.
I think for you, stick with the quad propulsion Trygve. Don't try this.
Yeah. And we didn't see any similar issues like that on the Sea Pioneer. There was a lot of other issues, of course, but we didn't see any cavitation issues.
No, you don't see the cavitation issues, but you still changed 3 or 4 main engines. Yeah.
Yes, you did.
In the first year, and I'm sure if you did install this equipment on board, you would find out that could probably be from cavitation. The jets, the MJP jets and the new Cameva jets and the Hamilton jets, they are all these days made from stainless steel. When we had, in the old days, when we had both small and big catamaran ferries, and also the first generation CTVs, crew boats for the wind industry, the Cameva impellers were aluminium, and there you could see. I mean, they were in every 6 months we had to build them up because there were holes through the impellers from pitting and cavitation. But these new stainless steel impellers, they are extremely durable. Maybe too durable because they just transfer all the power of the cavitation into the shaft and into the bearings and up through the whole drive line.
Could you add some more flexible couplings on that shaft or do something with to absorb it before the engines?
The first thing that I would do if it was something I had to do something with was definitely be that, because the couplings that were on were center couplings that were doing that were the first thing to explode in our faces. That's how we found out that they were custom made for these boats. They hadn't taken a standard coupling off the shelf, but they'd actually had some center custom make couplings for these boats. And that would definitely be worth looking into the specifications if there was something to be gained there.
Could I come in with a different question? And that is one of the advantages of an SES, as long as it is controlled with the vent valves, is a more comfortable ride. But the question is, okay, more comfortable, but more comfortable than what? You mentioned that you're operating at speeds which may be, let's say in the 40s of knots, when a normal CTV would be down at 25. What about the comfort level for the guys that are going out to maintain the wind turbines? Is there, how comfortable is it? Is there no sickness, or do people still get sick, or what?
Yeah, we've had quite a few issues with the seasick technicians, because in the beginning, if one of them got seasick, the boat had to turn around and they all had a day off. So almost every day one of them was seasick. And then they fitted cameras in the salon and they changed the procedure so that if one was seasick, he would just have to lay on the seat and stay there until the end of the day anyway. That reduced the seasickness about 95%. But having said that, we can see on the cameras that have been fitted in the salon that in rough weather, we can see that it is. I would say it's not totally smooth. For me, I've been sailing for 45 years. It takes a bit to surprise me, and I would say, but it wasn't more than I expected, definitely. And the comfort on a boat that's going at half the speed or a little bit less even. Of course, the movements are slightly, the weight is higher and the speed is slower, so the movement won't be that hard. It's quite hard movements on the boats because they are hovering. There's not a lot of displacement, so when they do hit a wave, you can see that it's a bit of a
bit more of a juddering movement than a kind of rolling. Yeah, I get it.
But so I would say not more than I expected, and definitely not something I would feel was totally
right.
Comfortable.
But then I guess that the people that are getting sick are people that let's say it are sensitive to motion sickness.
Yes, it's the same people that would get seasick on our conventional CTVs, definitely.
Yeah. Okay.
And the same amount, more or less.
Yeah. Thank you for that. It's this comparison between a slower boat and a high-speed boat. It's difficult to get the message across at times. Thank you.
Absolutely. No, I've been a fast ferry captain all my life, trying to convince the captains from the slow boats to get into the fast ferries. So this is just the next level.
Yeah.
And what we used to say is, would you rather be seasick for 1 hour or 2 hours?
Yeah. I think I would certainly prefer 1 hour.
Yeah. There was a hard one for the people who tried to resist the fast ferries to answer.
Yeah. Okay. Well, gentlemen,
may I ask one question?
Yeah, carry on.
My background is in the water jet industry. I'm very interested about the cavitation that you mentioned that caused vibration. Have you been in contact with MJP and what did they say about it? Just out of curiosity.
They said that at 0 speed, cavitation would come from 60% load with this power. What's also maybe important in this relation and is that we have jet CTVs with jet drives, but we have on a jet the same size as these ones, we have 600 kilowatt, not 1200 kilowatt or 1600 kilowatt. So we have about somewhere in between, a lot less than half the kilowatts in a jet this size. Okay. These are extremely, and that's why they can do the 50 knots, obviously. Sure. It's for water jets like any other propulsion system, you always have to choose, do you want bollard push or speed?
Correct.
And it's impossible to have the perfect propulsion system for a CTV, because half the time we want the speed and the other half the time we want the bollard push.
Yeah, you could maybe have a booster jet or something, but then it's more complicated, obviously.
Yeah, but Trygve has designed and built 3 boats in Singapore with quad jets. And I think that is probably one way of doing it.
Then obviously, as it's a SES, you have the air cushion. And I'm always curious, like, how do you keep the air out of because on the other side, you have the suction from the jet inlets. How do you keep the air out? Yeah,
there's we should explain that. Yeah, there is a fin sticking down about a foot on the inside to keep them, because we've had that even on conventional fast ferries. When you get enough air pressed between the hulls on the catamaran, then the water between the hulls is lower than the water on the outside. The the SES boats, the hull shape is actually triangular down towards the center, and then up. So that's
Yeah, makes sense.
Yeah, and then of course the intake for the water jets has to be not so canted. So on the in the wall towards the cushion, and Trygve can say a lot more about it, I guess, or also Roger. But the whole idea is to have this fence to prevent aeration or ventilation of the water jet intakes. But the challenge is that the design of those fences is you need to have a lot of experience to get that right. I think that's the basic thing to say. Am I right, Trygve?
I think Muni pointed to it quite correctly. It's about the trim of the vessel. So you need to trim the stern down sufficiently so you have sufficient water into your jet. And the more waves, the more kind of wave troughs you have. So you need the more aftwards trim. But on the other hand, you want to lift the stern to be as fast as possible. Yeah. So that's the kind of balance here, and that's why you trim the vessel with either fuel tanks or trim tanks or interceptors or foils or whatever to keep the trim right. And the right trim changes with the vessel speed, and it also changes with the wave height. So you need something for trim control.
Perhaps I should ask both of you and Mik, Trygve. Okay, so just hearing what you're saying, has this now been put in a program which would automatically adjust trim as you alter speed and sea state and so on, or is this still at the moment by hand?
For our designs, we have manual trim control.
It's manual.
Okay.
It's
a bit tricky because how do you get the wave height right? There are some parameters that you don't really get into your system. It's that's why we like to have them a bit aft heavy. So if the operator operates incorrectly, he's all good. He loses some speed, but he will still be okay. And if he does optimum, then you get the extra additional knots. But Mik, you were saying something, I think.
I agree. That is for us. We can definitely easily see the difference between a good skipper and a bad skipper on on marine traffic.
Right. Indeed.
And on the fuel consumption.
But as Mik mentioned here, we have some versions now with quad that solves some issues and gives some other issues, and we're also looking. We also have a solution with CPP for CTV. So there are options.
Very well. Any other questions, gentlemen? Well, it's quiet at the moment, so yeah.
Seems we've got around.
Yeah, perhaps if I could just finish off the question on training then. So how do you, or perhaps Mik or Roger, how would you train your skippers on these vessels versus a normal CTV? What would be the difference, or is it just essentially the same?
Yeah, they of course first of all we take the skippers that are motivated and feel that it's interesting to work with this type of technology, because if you don't have the motivation to do it and you just think you want to put the handle down and lean back and enjoy your day, this boat is not for you. You need to be motivated to try and play a little bit with the trim, with the interceptors, with the pressure of the lift fans, with a little bit of ballast when you are going with or against the seas or with the side seas, or I mean, an experienced skipper will train a a new skipper in something like 2 months.
Okay.
So they need to sail as chief officer or whatever we call it for at least a couple of months sailing time before they take over as skippers.
Okay. Thank you. Okay, if there are no more questions, I will ask Mike Mooney, our chairman, to give the vote of thanks, and thank you very much from myself as well, Mik and the guys at MHO, and thank you for today. Mike, over to you.
I'd like to thank the guys from MHO and of course Roger. Been a very interesting presentation and a lot to be learned from it. Obviously they've got problems, which at a later date, hopefully when they sort them out, they give us another presentation.